Okay, let's try another problem here. We have a problem that we did actually. There's a recording for this already. But what I didn't go over in that recording is to figure out um, what the distribution should be. And so the distribution requires us to calculate this idea of a pooled distribution. Now there's several ways to do that. The first way to do that is to gather all the information here, and you can find out the x, the n's, and stuff like that. So let's figure that out. We have let's read through this. Talking about antiperspirants for soldiers' feet, and they did an experiment, and one group of 328 West Point cadets put on alcohol-based antiperspirants on their feet. Now let's call that one for the population A, the first population. And the control group of 339 soldiers put a similar, but there's no active antiperspirants there, so let's call that NB. And there's 339 soldiers. Now in this particular problem, they gave us 21% and 48% had developed athlete's foot. So in this particular case, they don't give us X, but they give us a P. So for the first sample, PA is equal to, well, let's call it PA hat, is equal to 21%, and PB hat is 48%. And so the question is still, what is XA and what is XB? And remember that the relationship between P hat and X and N is that P hat is X over N, and so if you're looking for X, you can just multiply both sides by N. So in our calculators, what we can do is just take a quick look at what is 21% of 328, and 68.8, let's just call that an even 69. That's going to be important that we use whole numbers for this. Likewise for B, that's 48% of 339. And then we're going to get 162.7. Let's call that 163. So these are XAs and XBs, NAs, and NBs. So to get our PC, our pooled proportion, we need to add up the 69 plus 163 and divide that by 328 plus 339. Now when you do this in your calculator, you have to be careful, because if you just type in 69 plus 163 and then you put just a divide by 328 plus 339, this is going to give you an incorrect answer, because the calculator is going to read this and follow the order of operations and do this division first before doing any addition. So what would be good is one way to do it is to do this in two different steps. Add the numerator and divide by the denominator, add the denominator and then divide. Or if you want to do it in all one shot, you can insert parentheses that would cover all the numerator, and insert parentheses that would cover all the denominator. Oops, I think I put the wrong parentheses there. Let's just put a regular parentheses instead of a curly brackets. And then we should get a proportion that's considered a pool proportion. And in general, we want to round off to at least 4 digits. So let's say 3, 4, 7, 8. Actually, it might be better to round off even more. Let's say 3, 4, 7, 8, 2, 6. So that's the PC part. We need 1 minus PC, and then we need to do this division. So again, if you're comfortable with a calculator, you can run through and punch all that stuff in. So let's do that. So we're going to need a square root. So second function, square root. So that begins my square root. I got my PC, so I'm going to put 0.347826 times, and then I'll open it up with a parentheses, and then I have 1 minus 0.347826. So I'll close a parentheses for that, and then now I'll open up another parentheses, and then I have a 1 divided by n, a, so that's 328. Now for this particular expression in the parentheses, I have a plus here, and it's okay to not have parentheses within there. I mean, just to be safe, you can put a parentheses around 1 divided by 328 for this expression, and then another parentheses here. But since the calculator does multiplication division first before addition, it's going to know to compute that division first. So the second expression, the second term, is 1 divided by 339. And then now I'll close this parentheses that got opened up, and technically there's a parentheses around the whole square root, and so if you forget that parentheses, it's not going to be that big of a deal. If you forget the first one though, a calculator will complain. So let's just finish that up. Alright, so this is going to be the standard deviation that we're going to use. So it looks like our distribution is a normal distribution centered around 0 with a standard deviation that's really small. 3, 6, 8, 8, 8. However far they want you to round off. So let's actually check our homework. And I have it pulled up here. Let's just check this particular answer here. So we're using the normal distribution, and we have a 0 here, and our standard is 0 for the mean. Our standard deviation round to 4 decimal places. They say 0.036. Let's just call it 9, and let's just check our answer for part D. So that looks like it worked out. Alright, so the lesson here is a complicated formula, and at this point I don't have any quick shortcuts to be able to simplify this. Maybe before the end of the semester I'll try to see if I can write a quick formula that would have you calculate this, but it's just a matter of following this and then going to, if the actual answer is asking for 4 decimal places, then you'd better go at least 5, maybe 6 decimal places for your intermediate calculations. So doing 4 decimal places in the intermediate calculations is not going to give you 4 decimal places accuracy in your end calculation, so we got to be careful about that. Alright, I hope this helps.